Good morning, students. Uh, Today we are going to see uh, properties of determinants. We are going to see the topic called properties of determinants. Okay, in which some six properties are there. Okay, so after learning the six properties, by using these six properties, we are going to solve certain problems. Okay, I am Max teacher Santosh Kumar. I am a teacher in Kola Saraswati School, which is in Kill Park. Okay. Okay. Anyway, we'll start the topic, which is properties of determinant. What is mean by properties of determinant? Okay. Six properties are there. I told you. The first property is, which is determinant of A is equal to determinant of A transpose. First property is determinant of A is equal to determinant of A transpose. Okay. It's a property. Determinant of A and determinant of A transpose both will be same. They are saying. Okay. If you check, it will be equal. You can check it. You can take any matrix A and find its determinant. Also find the A transpose and find its determinant. Both will be equal. Both will be equal. Okay, now second property is what? If each element in a row or in a column, okay, if each element in a row or a column of a determinant is 0, then the value of the determinant is 0. This is second property. What they are trying to say here, that means in a row, right? This is a textbook statement. What I want to say is, if in a determinant, if any row or any column is completely 0 means, then the value of the determinant is 0. Once again, I'll tell you, in a determinant, if any one row or one column is completely 0, then value of the determinant will be 0. That is what property number 2 says. Okay, so you can take this example. If you take this example, this is 2 cross 2 determinant, right? 2, 5 and 0, 0. If you do cross multiplication, obviously this value is going to be 0. So one row is completely 0 means value of the determinant is 0. Okay, similarly, example 2 you can take, and it can be for 3 cross 3 also, it is applicable. Okay, so one row is fully over here 0. So if we expand this determinant value, the value of the determinant will be 0. If we expand this determinant, the value will be 0. You can check it, right? Determinant say expansion, I told you, we have seen in the lecture 1 itself. Okay, Determinants Lecture 1 itself, we have seen how to find the determinant of 3 cross 3 matrix. Okay, then next, so property number 2 is over. Property number 3 now. Property number 3. What property number 3 says? Very simply, I'll tell you. The statement and all not required. You, by example itself, I can make you to understand. Okay. Anyway, the statement. What the statement says? If any two rows in bracket or columns of a determinant are interchanged, then value of the determinant changes by sign alone, by sign only. Meaning is, see, if we interchange this row and this row, the 2 and 5 and 1 and 2, if we interchange these two rows, it will be equivalent to, right? Outside you can make one negative, you can put one negative because you are interchanging, so if you interchange, one negative will be extra over here, then only these two will be equal. This is what they are saying. Okay, so if we interchange any two rows, sign of the determinant changes. Okay, so if you are interchanging any two rows, interchanging is allowed, but one negative will be extra. That's it. Okay, easy. Yeah, next property is property number 4. Property number 4 is what? This one. Common factor can be taken out from a row or column. Okay, you will not be able to understand because this is my own statement. I'll tell you the example. Right, the example you take alpha x and alpha y here, beta gamma. Right, in this row you see alpha is common, so you can take alpha outside. Remaining one is x and y is as it is, right, and beta and gamma is as it is. That means what they are saying is, in this fourth property, what they are saying in a row or in a column is, if there is a common factor, you can take it out. Okay, common elements, you can take it from either from a row or from a column, because it is determinant. Okay, whereas in matrices, if you want to take a common element outside, if you want to take, you have to take from each element. But in determinant, you can take either from a row or from a column itself. Okay, understood? Very simple. But in matrices, you need to take common elements. If you are taking common elements outside, it should be common for what now, all the elements. You can take it out from each element only. But in determinant, it's not like that. In one row alone, if it is common, or one column alone, if it is common, you can take it out. Okay, that's a fourth property. Now, fifth property we are going to see. Property number 5. Property number 5 is this one. Okay, if any row or column is a sum of two quantity, then such determinant can be expressed as sum of two determinants. I mean, what is the meaning of this one is, listen, look at this meaning, I'll tell you. See, if one row in a determinant, one row is sum of two quantity like this, then you can write this determinant into sum of two determinants. Right, again I repeat, one row or one column is sum of two quantity. Sum of two quantity means that determinant you can write it as sum of two determinants. This determinant you can write it as sum of two determinants. Okay, how to write is, listen, the combination of first element you have to take. Here sum of two quantities are there are also sum of two quantities. Pick up the first elements alone, alpha, beta. So that alpha, beta you put here, and this is a repeated row only, as it is you have to write, right, which is a repeated row only. Fine, once again, yeah. So P and Q is a common for both the determinants. While splitting, it will be common for both. And so for the first determinant, what you have to take is some, right, first elements you have to take, collection of first quantity. Next, plus collection of second quantity. So x and y over here, and then P and Q again repeats. This is for one row is over here, sum of two quantities, right? This is applicable for column also. Column also it is applicable. This is property number 5. Okay, property number 6 now. Property number 6 is, already you studied about this one. This is there in the elementary transformation. Which is Ri tends to Ri plus K times Rj is applicable, or else this is also, when this is applicable, this also you can apply, it is acceptable. Okay, this also you can do. Ri tends to Ri plus Rj plus Rk. That means you can take any one row. Row 1 tends to row 1 plus row 2 plus row 3. You can do, right? And column operation is also allowed here. Ci tends to Ci plus K times Cj, or else Ci tends to Ci plus Cj plus Ck. This is also allowed. Column 2 is equal to column 2 plus column 3 plus column 1, like that also you can do. Okay, and note, this is very, very important note, because what you know, in a determinant problem, both row method and column method you can do it, you can apply it. Both row operation also you can do, column operation you can do in the same problem itself. In a single problem you can apply both. But whereas in matrices, if you are starting with row operation, you have to do only with row operation. That concept is different. This is different because that is coming under right cancellation law and left cancellation law. Okay, so what I am saying, in determinant, right, simultaneously, I mean for a same problem you can apply both. Okay, whereas in matrices, in elementary transformation, once if you are starting with row method, you have to complete that sum by row method only. You in between you cannot apply column method. But in determinants, you can apply, right, first step you can try by row method, second step you can do by column method also. It is applicable. That note is only I have written over here. In a determinant we can use column and row operation in the same problem I expressed. That's it. Okay, anyway, properties are only up to 6 properties, right? This is one simple concept. Anyway, you learned this also. Okay, properties are over, 6 properties are there, over. I'll recollect that one, recall all those things. Now about area of the triangle formula. In determinants we have area of the triangle formula. That is, area of the triangle is half into mod of x1 y1, right? You know, when 3 vertices are given, this is x1 comma y1 you can take, x2 comma y2 you can take, and x3 comma y3 you can take. So when 3 vertices are given, you can find out the area of the triangle by using this formula. Okay, see, this formula is nothing but, in 10th standard you studied one formula, which is half into, right, mod of x of y minus y plus x of y minus y plus x of y minus y. Okay, this formula only, this one, right? Actually, when you expand column 1 in this determinant, when you expand column 1, it will be equal to this one. So that means, what is this one? This is area of the triangle. So area of the triangle in determinant form is this one. Okay, and about collinear, whenever area comes, you know, collinear will be there, right? When 3 points are collinear, what will happen? We cannot find out any area. So in that case, this determinant value, this part will be 0, because area will be 0. So 1 by 2 cannot be 0, only this will be 0. Okay, so simple, very simple thing. If 3 points are collinear, then this determinant value will be 0, right? If they ask area of the triangle, this is the formula for area of the triangle. How we got that formula, I told you. This is when you expand by column 1, if you expand, you will get this one. Actually, it is area of the triangle that you have studied in 10th standard itself. Okay, very good. Properties are over, right? 6 properties are over. I'll recall the properties. You just see. Property number 1 says, determinant of A and determinant of A transpose are equal. Property number 2 says any one row or any one column is completely 0, means value of the determinant 0. Property 3 says if you interchange any 2 rows, one negative will be pulled out. Property 4 says common elements you can take it from either a row or from a column alone. Okay, that's property number 4. Property number 5 is what? Any one row or one column is sum of 2 quantity, like this. Then you can write the whole determinant into sum of 2 determinants. This is property 5. Property 6 already we studied in elementary transformation. That's it. Understood? Easy, right? Max is very easy when you go by proper way. Fine. Thank you. Solving the problems we will see in the next session. Thank you.